As I look at this integral, I can see that U substitution would not work, so I'm going to try trig substitution. I am going to draw a triangle such that one of the sides will be the square root of x squared minus 16. So this side needs to be x, and have this side be 4, so that this side would be x squared minus 16. Here's my theta. So the trig function to relate these two, and I want x to be on top, so that's going to be secant theta. That's going to be hypotenuse over adjacent. And so x would be 4 secant theta, and dx would be 4 secant theta tangent theta d theta. I have everything figured out then to do the substitution. Dx is 4 secant theta tangent theta d theta, and that's over x squared, so that's going to be 16 secant squared theta multiplied by the square root of 16 secant squared theta minus 16. Then, as usual, we're going to factor out the common thing here, which is 16, and that'll leave us secant squared theta minus 1 underneath the square root, and then we can replace that secant squared theta minus 1 with tangent squared theta. And the last thing we can do on that is go ahead and square root that. And let's also do a little bit of reducing. I am going to take this 4, reduce it with this one, get a 4, and this secant, and we'll get rid of one of those. And if I square root this, so left on top I have tangent theta d theta, and on bottom I have 4 secant theta, and then I have times 4 tangent theta. And I can do a little more reducing then. I can cancel out these tangents. So what I really have here is 1/16, and this is, so I move these out in front, 1 over secant. Well, that's just cosine theta. And then we have d theta. So that's going to be 1/16 sine theta plus a constant. One last thing to do then would be to resubstitute. So we want to get this back in terms of x. So we have 1/16, and sine theta, going back to my triangle, sine is opposite over hypotenuse, so square root of x squared minus 16 over x plus a constant.